One is a double displacement reaction. When we are talking about the double displacement reaction, you understand what is happening. The double displacement reactions are of two types. One is the precipitation reaction. One is the precipitation reaction. And one is the neutralization reaction. And one is the neutralization reaction. You understand? So when we are talking about the double displacement reaction and the precipitation reaction, when we are talking about the precipitation reaction and when we are talking about the neutralization reaction, what exactly does that mean? Just understand. So first of all, double displacement would mean what? The exchange of
Exchange in
ions.
radicals.
The exchange of ions is what you call as a double displacement reaction. Double displacement reactions are what? The exchange of ions is called as the double displacement reaction. So a very simple reaction that we do is we have PbNO3 whole twice plus Ki. Okay. So what is going to happen? You understand when we are talking about PbNO3 whole twice, how do you break down? You have Pb plus 2 and you have NO3 minus 1. You have K plus 1 and you have I minus 1. Are you understanding?
Yes, ma'am.
So positive of first compound, that means this is compound 1 and this is compound 2. So what would happen? Just tell me. What would happen? You will have positive of one compound combines with the negative of the other, and positive of one compound combines with the negative of the another. Are you understanding?
Yes, ma'am.
So it is going to form what? It is going to form PbI2 plus
Yes, ma'am.
KNO3. Why? Because Pb plus 2 has to be done the crisscross with PbI2 and K plus has to be done the crisscross with NO3 negative. So what does it form? It forms KNO3 and PbI2. Did you understand?
Yes, ma'am.
And PbI2 is going to be a yellow precipitate. What do you mean by precipitate?
Many
What do you mean by
insoluble,
precipitate? A precipitate would mean what?
many insoluble substance form when the two compounds in aqueous state react with each other.
Right. So
Any
precipitate means any insoluble substance in water. Any insoluble substance in water is called as what? Is called as the precipitate. Are you understanding?
Yes,
So
ma'am.
PbI2 is insoluble in water. So you have to understand this way. You have to understand this way that whenever we are doing a double displacement reaction, the first understanding of the reaction is that it has two reactants and hence the final products must also be two. Do you understand?
Yes,
So
ma'am.
you can see here it is compound 1 plus compound 2
Compound
to
two.
give me compound 3 plus compound 4. Did you understand my point?
Yes, ma'am. Yes, ma'am.
Right. Now have a look here again. So let's suppose this is a double displacement reaction. And in this double displacement reaction, what is going to happen? Just tell me. In this double displacement reaction, what exactly do you think is going to happen? Just tell me. That PbI2 here shall be formed as a precipitate. Are you understanding my point or not?
Yes, ma'am.
Next, what do we have here? Let's say we have AgNO3. Now you have to understand that this is silver. This is silver nitrate.
Nitrate.
And silver nitrates reacts with KCl. So it forms what? It forms what? It forms K plus and Cl negative and Ag plus and NO3 negative. So positive goes with negative and positive goes with negative. So it forms what? It forms
AgCl.
AgCl and it forms KNO3.
KNO3.
So AgCl is going to definitely form a what? A white
White
precipitate.
precipitate. And
So first thing you have to understand about the double displacement reactions is that, ma'am, the two reactants that we are taking here in this example, we took what? We took AgNO3 and we took KCl. Did you understand? So
yes,
when we
ma'am.
took AgNO3 and when we took KCl, you understand what is going to happen. You understand what is going to happen. So when we took AgNO3 and KCl, both of these salts must be soluble salts. In the reactant, the salt, soluble salt, and this must also be what? Soluble salt. Did you understand the point? So
Yes, ma'am.
AgNO3 is also a soluble salt and KCl is also a soluble salt. Right? So let's suppose if you say that, okay, ma'am, I'm going to take AgCl with KNO3, then this reaction is not going to take place. Why? Because KNO3 is soluble and AgCl is forming a precipitate. Did you understand? So
Yes, ma'am.
sometimes when you're given a particular reaction, you have to understand what? That, ma'am, when we have AgCl and when we have KNO3, you understand? What exactly do you think is going to happen?
Ma'am, this reaction will not be possible. This AgCl and KNO3 reaction.
Right. Did you understand my point?
Yes, ma'am. But
So here,
ma'am, sir,
what do you think?
ma'am, there are like two precipitates, ma'am, they which are soluble like zinc hydroxide and lead hydroxide. So, ma'am, in that case, can the reaction be possible or
No.
not?
The two salts that you're taking in the reactant side both have to be soluble. Very simple. When you say soluble, that means AgNO3, when it is soluble in water, that means on dissolving it in water, it is giving you the anions and the cations. KCl is giving you the cation and the anion. You understand? But when
Yes,
we are
ma'am.
talking about what? When we are talking about AgCl and it is a precipitate, that means AgCl cannot or is not dissociating into. AgCl is not dissociating into what? Is not
Yes.
dissociating into its ions.
But
Did you understand my point?
Can ZNOH or like PbOH whole twice, ma'am, can they like dissociate into their
In the
ions
hot water,
because?
in the hot water, in the hot water. Primarily, they would in the cold water form the PPT. Okay.
Okay, ma'am.
Did you understand my point or not?
Yes, ma'am.
Right. So just have a look here. So when we have AgCl, when we have AgNO3, when we have KCl, K plus and Cl negative, this is the concept that you got to understand. Got my point or not?
Yes, ma'am.
Right. Now understand. On the similar note, so we have AgCl, we have KCl, we have AgNO3, all of this. Now you understand. Now you understand. So let's suppose if I give you AgNO3. So first important point is that you remember the color of the precipitate. So let's suppose if I give you KBr. So what is going to happen? K plus and Br negative. And it is going to form what? It is going to form Ag plus and NO3 negative. So positive goes with negative and positive goes with negative. So it forms what? It forms AgBr and
GBR.
it forms KNO3. Did you understand my point?
Yes, ma'am.
Got my point. So it is going to be AgNO3 plus KBr. And AgBr is going to form a pale yellow. Is going to form a pale yellow precipitate. Did you understand my point?
Yes, ma'am.
Right. Similarly, we would have what? AgNO3 and we would have Ki. And it would form what? It would form AgI plus KNO3. Did you understand?
Yes, ma'am.
So we have Ag plus and we have NO3 minus. We have K plus and we have I minus. So AgI is going to form what? It is going to form a dark yellow precipitate. Are you understanding?
Yes, ma'am.
So all of these are what? These are double displacement reactions. So what do we have? Ag goes with Br negative, K plus goes with NO3 negative. Ag goes with I negative, K plus goes with NO3 negative. Did you understand my point?
Yes, ma'am.
Any doubts in this?
No, ma'am.
Right? Similarly, if I'm talking about what? When we are talking about Ag, now let's suppose I talk about barium chloride. I would have BaCl2 plus if I talk about Na2SO4. So how does this reaction takes place? You understand? Na2SO4 breaks down into Na plus and SO4 minus 2. BaCl2 breaks down into Ba plus 2 and Cl minus 1. So positive goes with negative and positive goes with negative. So it is going to form what? BaSO4
Ma'am,
and
BSO4
it is going to
plus
form
2
NaCl.
NaCl.
Yes. So this is going to be what? A white precipitate. And this is going to be a white precipitate. Barium sulfate is going to be a white precipitate. Did you understand?
Yes, ma'am.
Right. So you have to understand it this way that whenever we are doing the precipitation reactions, Now the target is that, ma'am, this time when you make the equations, so you have told me that okay, BaSO4 forms a PPT and NaCl does not form the PPT. So in case if you give me any other random equation, how would you be able to tell me that which is the precipitate and which is not the precipitate? How would you be able to understand that? How would you be able to understand that? मैंने कहा यार, समझ में आई? So how would you say that? Just see. So you have to understand that there is a precipitation table. That there is a precipitation table. Now, what is this precipitation table? Just understand. When we are talking about the precipitation table, you have to understand one very important part. One is what? One is number one, that ma'am, all salts of sodium, potassium, and ammonium are always positive. You understand? All salts of sodium, potassium, and ammonium are always soluble.
Then they will not make precipitates.
No matter what, yes, never. Are always soluble. That means you talk about any salt. Let's suppose you say NaCl, you talk about NaBr, you talk about Na2SO4. So they're always soluble. You talk about KCl, Ki, you talk about ammonium sulfate, NH4 whole twice SO4. All of these are always soluble,
Yes,
right?
ma'am. Yes,
Next
ma'am.
is next is all carbonates, all phosphates, all acetates, all nitrates, all carbonates are always insoluble and form precipitate
Okay, ma'am.
and form precipitate.
Now even
You understand?
hydroxides also form precipitate. But
Precipitates. But if
ma'am,
you talk about NaOH, then it is not going to form the precipitate because Na, K, and ammonium, these are three cations whose salt you're never going to form as a precipitate. Did you understand?
yes, ma'am.
Right. So you understand. So let's suppose if you talk about what? If you talk about so all carbonates, phosphates, acetates are always insoluble and they form precipitate. Did you understand?
Yes, ma'am.
On the similar note, what do we have? Now see, all hydroxides also form precipitate. All hydroxides also form precipitates, right? Except NaOH, LiOH, KOH, RBOH, CSOH, MgOH whole twice, BeOH whole twice, calcium hydroxide, strontium hydroxide, etc. You understand? So this is also very important. So all carbonates, phosphates, acetates are always insoluble and they also form precipitates. Understood or not?
Yes, ma'am.
Right. All hydroxides also form precipitates except NaOH, LiOH, KOH, RBOH, etc. Got my point?
Yes, ma'am.
Right. So now let's suppose, and also you have to understand that all nitrates are always soluble. All nitrates are always soluble. Did you understand?
Yes, ma'am.
Right. So this is the concept. All nitrates are always soluble. Let's suppose if you say AgNO3, KNO3, right? MgNO3 whole twice. No matter what nitrate you take, all of them are always soluble. Next is all salts of silver. All silver salts are always insoluble and form precipitate except silver nitrate and silver fluoride. These two salts are always soluble. These two salts are always soluble. Did you understand my point?
Yes, ma'am.
Right. So this is very, very important. This is very, very important. Got the point or not?
Yes, ma'am.
Okay. So you understand a very important point here. It says what, that all silver salts are always insoluble and they form precipitate except AgNO3 and AgF. Right. So now if I give you this equation, that, and also you have to understand all nitrites are insoluble. All nitrites are insoluble. Got my point? So these
Yes,
are
ma'am.
going to be my solubility rules.
All
All
nitrites.
nitrates and all acetates also. Again, if I say acetate, acetate is CH3COO negative. Now the anion you have fixed out. The anion you have fixed is acetate. Do you understand? The anion you have fixed is acetate. But cation, but cation,
Cation like
cation, if it becomes Na plus K plus and ammonium, then definitely this, even this acetate would be soluble. That means if you learn a rule for, cation, or if you learn a rule for anion, when you say nitrate, irrespective of the fact what is the cation, all nitrates would be soluble. If you say that all salts of sodium, potassium, ammonium are soluble, that means, what does that mean? What does that mean? Tell me. So all
ma'am,
nitrites
please
are
repeat.
soluble. Yes.
Ma'am, please repeat.
I'm saying if you're learning the rule for nitrites, you understand?
Yes, ma'am. Yes, ma'am.
If you learn the rule for nitrites, what exactly does that mean? Just tell me.
Ma'am, like all nitrites are insoluble. Ma'am, when sodium, ma'am, like when sodium nitrite, ma'am, when
Yeah.
they
So all
combine with,
nitrites are insoluble,
yes, ma'am.
right? But you have to remember the case that, when you talk about NaNO2, then that would be soluble.
Yes, ma'am.
You understand? Because we have learned the rule for sodium. And when we say that sodium becomes a cation, irrespective of whatever is the anion, the salt becomes soluble. You understand?
Yes, ma'am.
So you also have to understand that all bicarbonates, all sulfides form PPT.
Yes, ma'am.
You understand? Then you say
Yes, ma'am.
all chlorides, bromides, and iodides are soluble except PbCl2, Hg2Cl2, and AgCl. These are insoluble. Except these, all chlorides, bromides, and iodides are soluble. Similarly, if you talk about PbBr2, Hg2Br2, and AgBr, they are insoluble.
Yes, ma'am.
Rest all of them are soluble. So all chlorides, bromides, and iodides are soluble except PbCl2,
Ma'am, after
Hg2Cl2.
PBBR2, is it written Hg2Br2?
Yes. And similarly, we have PbI2, and we have AgI, and we have Hg2I2.
But how is that? But how is mercuric bromide the formula forming Hg2Br2? Or shouldn't it be HgBr2?
No, no, no. There is a reason why am I writing this down. I'll explain it to you later on. But did you understand the concept?
Yes, ma'am.
So these are certain rules. So now next time if I give you this reaction, if I give you KBr and if I give you PbNr2, PbNO3 whole twice, and I ask you that whether this reaction will take place or not, you will apply the solubility rules. You will say that all bromides are insoluble, all bromides are soluble, and all potassium salts are also soluble. Hence, this salt is soluble.
Yes, ma'am.
And we know that all nitrates are soluble. So this is nitrate, irrespective of the fact that what is the cation. Hence, it is also soluble. Did you understand?
Yes, ma'am.
And thereby, what do we say? Thereby, what do we say? That we say that when we are talking about this, so this is K plus and Br negative, and this is Pb plus 2, and this is NO3 negative. So if I make the compound, if the reaction, if I between these two, so what exactly happens between this? This becomes KNO3, and this becomes PbBr2. Did you understand? So this becomes PbBr2. And now you tell me whether this is a double displacement reaction. You will say yes, it's a double displacement reaction. But if I
Yes,
ask you that, tell me whether it is a precipitation reaction or not, what will you say? That yes, it is a precipitation reaction.
yes,
Why?
ma'am. It is a prison.
Because
Ma'am,
PbBr2 is
because
there.
yes, ma'am.
Did you understand? Similarly,
Yes,
if I
ma'am.
talk about Ki, or let's suppose if I talk about KCl, and I ask you to make the reaction in PbNO3 whole twice,
Yes, ma'am.
and then the reaction takes place, then what do you mean by this? This is K plus and Cl negative, and this is Pb plus 2, and this is NO3 minus 1.
Yes, ma'am.
So positive goes in negative and positive goes in negative. So it is
Ma'am,
going to
this is a
form what?
Ma'am, this is a precipitation reaction.
This is a precipitation reaction. Because how did you identify this? Because
Ma'am,
you
because
already
all
know the
potassium
rules,
salts are soluble
right?
and
All
all the
nitrates are
nitrates are
soluble.
soluble.
This is nitrate, KNO3 being formed. Nitrates are soluble, but PbCl2, all chlorides are soluble except lead, mercury, and silver. Did you understand? So all
Yes,
chlorides are soluble except lead, mercury, and silver. Very simple. So we know that PbCl2 is a precipitate being formed. Did you understand my point?
yes, ma'am.
Yes or no?
Yes, ma'am.
Any doubts in this?
No, ma'am.
Next, what do we have? We have NaNO2 plus AgBr, AgF. If let's suppose I give you this. Now you tell me, is this reaction possible?
Um,
NaNO2 is sodium salt.
yes, ma'am.
All
Ma'am,
sodium salts are soluble.
yes, ma'am. Ma'am,
AgF is the only salt of silver which is soluble because silver has two salts which are soluble, AgNO3 and AgF.
yes, ma'am.
You understand? So when we are talking about this, so this is also soluble. So first of all, my reactants are soluble.
Yes, ma'am.
My reactants are soluble. Yes or no?
Yes, ma'am.
So if the reactants are soluble, that would mean that it is going to break down into its respective ions. So this is positive and this is negative. Now the positive goes with negative and the negative goes with positive. So I get NaF and I get AgNO2. And after that I know that all salts of silver form PPT except AgNO3 and AgNO3. That's the rule. So I know that this is the double displacement reaction also. And because in this reaction a precipitate is being formed, so it is a precipitation reaction also. Are you understanding my point or not?
Yes, ma'am.
Any doubts in this? Right.
No, ma'am.
So this is the concept. This is the concept. So what are we doing? We are doing the precipitation reaction, the double displacement reactions also. Are you understanding or not?
Yes, ma'am.
Right. So you have to read the statements and then get to the answer. Let's suppose if I give you ammonium chloride plus K2CO3 and I ask you to do the reaction. So you have one rule that all carbonates form precipitate except sodium, potassium, and ammonium. So when we are talking about ammonium chloride, what does it happen? It is ammonium plus and Cl negative. This is K plus and this is CO3 minus 2. And this is what? Ammonium NH4 plus. And this is Cl negative. So positive goes in negative and positive goes in negative. So what does it form? It forms NH4 whole twice CO3 and it forms KCl. Now you tell me whether it is a double displacement reaction or not. So you say NH4Cl is there.
Yes, ma'am.
Did you understand? And
Yes, ma'am.
K2CO3 is there. So this is going to be potassium carbonate. And this is going to be ammonium chloride. Did you understand? So this is ammonium chloride and this is potassium chlorate, carbonate. So
Yes, ma'am.
potassium carbonate, now we know that all the carbonates are insoluble except potassium, right?
Yes, ma'am.
But ammonium chloride is definitely there. What is ammonium chloride?
Ma'am,
What is
solid.
ammonium chloride? Exactly.
Solid.
So it's a solid and it's a soluble salt because it is ammonium salt.
So it will form the precipitate.
Yeah. So positive goes in negative and positive goes in negative. So it forms ammonium carbonate and it forms KCl. Now this is definitely a double displacement reaction. But you tell me whether it is a precipitation reaction or not.
Yes, ma'am.
It is a double displacement reaction, but it is not a precipitation reaction. Why?
Oh, ma'am, because like, ma'am, ammonium chloride, ma'am, that ammonium salts, ma'am, all the other ammonium salts are soluble, but ma'am, potassium carbonate, ma'am, all carbonates are soluble except sodium and potassium.
Right. So we have ammonium carbonate and we have KCl.
Yes, ma'am.
Got my point or not?
Yes, ma'am.
Got my point or not?
Yes, ma'am.
That's the concept. Any doubts in this or not?
No, ma'am.
Right?
Yes, ma'am.
Why? Because all potassium salts are soluble and all ammonium salts are also soluble. Got it or not?
Yes, ma'am.
Now understand. What do we have? Now let's suppose if I give you now tell me. Is this reaction possible? AgNO3 is the only salt of silver which is soluble.
Yes, ma'am.
And K2CO3 is the sodium is the salt of potassium.
Excuse, ma'am.
Yes.
Ma'am, earlier you have written that all the carbonates and phosphates and all they are soluble, all they form precipitate.
Except for sodium, potassium, ammonium.
I think you have
Except
not
for
written that.
no, yeah, but obviously the rule you have learned already, right? So you have to remember except for sodium, potassium, and ammonium. Similarly for
Yes,
this also, all hydroxides are PPTs except for ammonium, lithium, strontium, rubidium, potassium, and sodium, etc. Did you understand?
yes, ma'am.
So we have AgNO3 plus K2CO3. And how do we carry out the reaction? So we have Ag plus and we have NO3 negative. K2CO3
Okay.
you break down as K plus and CO3 minus 2. So positive goes with negative and positive goes with negative. So what do we have? We have Ag2CO3 and we have KNO3. Now you tell me, is it a double displacement reaction?
Yes, ma'am. It is.
Yes, it is. But is it a precipitation reaction?
No, ma'am.
Let's check. Check the solubility rules. KNO3 is potassium salt and nitrate salt. We know that all salts of potassium are soluble. Are you understanding?
Yes, ma'am.
All salts of sodium, potassium, and nitrates are always soluble. Are you understanding my point?
Yes, ma'am.
And what about Ag2CO3?
Ma'am, Ag2CO3, ma'am, I think it will be insoluble.
Insoluble. So it is going to form the PPT, right? Because all carbonates are insoluble and silver salts are insoluble.
But ma'am, ma'am, in this case, ma'am, the already K2CO3 is insoluble. So, The K2.
K2CO3, it is a carbonate, but it is a potassium salt.
Acha, acha, acha.
Oh,
Oh,
so it is
oh,
soluble.
acha. Oh, okay, 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 ma'am.
This is also soluble. Hence, the reaction will take
Ah,
place.
okay, ma'am. Okay, ma'am.
Did you check the concept? Now solve this. If I give you CH3COONA plus MgCO3, tell me.
Ma'am, CH3CONA.
Its name would be what? Sodium. That positive's name you write first. So this is sodium acetate
Yes, ma'am.
and this is magnesium carbonate.
Yes, ma'am. Uh, ma'am, but I think, ma'am, sodium acetate. Uh, ma'am, MgCO3, ma'am, it will be like insoluble. Magnesium carbonate will be insoluble.
Right. Right. So this reaction is not even possible.
Yes, ma'am. And sodium acetate, ma'am, like I think it's also insoluble.
Now let me give you this. Now let me give you MgCl2. Then will it be possible? Sodium acetate is soluble, no doubt.
Ma'am, acetate is soluble and acetite are insoluble.
No, acetate is one thing. There is nothing called acetite. Acetate is soluble, definitely.
So, ma'am, actually, somewhere you had written that solve the along with all the nitrates are insoluble, and along with it, you had written something like C O O.
I have written all nitrates are soluble. All
All
nitrates
nit
are
all
soluble.
nitrates are insoluble and acetate is.
All nitrates are soluble, except for all nitrates are soluble. There is no exception in nitrate. Then I said that all nitrites are soluble.
All nitrates are insoluble. Yes, ma'am.
Yes.
All nitrates. Oh, yes, ma'am. Sodium acetate is soluble, and magnesium chloride. Magnesium chloride, ma'am. Even it is also soluble because all chlorine salts are soluble.
Yes. So we have sodium acetate, which is soluble. Yes or no?
Yes, ma'am.
Now you tell me. So negative goes with positive. So what does it becomes? It becomes Mg plus 2 and it becomes Cl negative. So negative goes with positive and positive goes with negative.
Yes, ma'am.
So what do we have? We have CH3, COO whole
CH3.
twice Mg, and we have NaCl. Did you understand?
Yes, ma'am.
So what do we have? This is an acetate. Now this is an acetate of
Acetates are
magnesium. And we know that all
acetates
acetates
are
form
soluble.
PPT. No, all acetates form PPT.
Uh,
All
all
acetates
is,
are insoluble, isn't it?
but sodium acetate is soluble.
But this is magnesium acetate, the final
Acha.
product.
Oh, okay, okay. All acetates are insoluble. Okay.
Right, except for sodium potassium. So this is going to form a precipitate.
Okay, ma'am.
And this is sodium chloride.
Okay,
Did
ma'am.
you understand?
Yes, ma'am. I'm understood.
Any doubts in this?
No, ma'am. Ma'am, except for NaCl, ma'am, except for NaCl, ma'am, are there any other exceptions for like
No,
chlorine salts
all
we need?
chlorides are soluble except for mercury, lead, and silver. That's it.
And ma'am, अच्छा नहीं, sodium chloride.
Got it?
Yes, ma'am.
Now let's suppose if I give you AlCl3 plus NaOH. Now how would you solve this? AlCl3 you break it down as Al plus 3 and Cl minus 1. And NaOH you break it down as Na plus and OH negative.
Yes, ma'am.
So positive goes as negative and not positive goes negative. So it forms what? It forms NaCl and it forms AlOH whole thrice. So this is aluminium.
Hydroxide. I think aluminium hydroxide, it
Would
is a
form a precipitate.
precipitate.
Yes. Because the basic rule is that all hydroxides form precipitate except for sodium, potassium, and ammonium. Simple. So
Sodium,
aluminum
potassium,
hydroxide, yeah. Whenever the cation is sodium, potassium, and ammonium, it is always going to be soluble, no matter what is the anion with it.
okay, ma'am.
You understand?
Yes, ma'am.
So we would have aluminium hydroxide,
Precipitate.
precipitate. So this is the concept.
Okay, ma'am.
Understood or not?
Yes, ma'am.
Right. So this is the concept that we have. Right.
Yes, ma'am.
Now understand. Next, we have the double displacement reactions. The next category of the double displacement reactions is the neutralization reactions. So now, did you understand how to identify a double displacement reaction and to check
Yes, ma'am.
whether that double displacement reaction is whether that double displacement reaction is a precipitation reaction or not? Now understand what is a neutralization reaction. It is a reaction between an acid
And a base.
and a base to
To form
form
salt and water, salt and water.
salt and water. Okay. So basically, when we are talking about the neutralization reaction, what happens is, now understand what is an acid. When you say HCl, when you say NaOH, you understand. So what
Yes,
is
ma'am.
HCl? It is H plus and Cl negative. And what is NaOH? It is Na plus and OH negative. So positive goes in negative and positive goes negative. So what are bases first of all? What are bases which contain OH negative? And what are acids which contain H plus? So acids are those substances which contain H plus, and bases are those substances which contain OH negative. Are you understanding? So
Yes, ma'am.
bases contain OH negative as the anion, and acids contain H plus as the cation. Did you understand my point?
Yes, ma'am.
Right. So bases contain OH negative and acids contain H plus. Did you understand? Now
Yes,
you
ma'am.
understand. So what exactly happens is just this. Just see this. So when we take NaOH and we add HCl, so you know that HCl breaks down into form of H plus and Cl negative, and NaOH breaks down in the form of Na plus and OH negative. So this is going to form what? This is going to form NaCl, and it is going to form water. Do you understand?
Yes,
So
ma'am.
water is water definitely, and NaCl is what? NaCl is sodium.
Sodium chloride, salt.
Is sodium chloride salt. Did you understand?
Yes, ma'am.
Any doubts?
No, ma'am.
Right. So similarly, if I say CaOH whole twice and we have HBr, so it is going to be H plus and Br negative. And CaOH whole twice is a base. Its name is calcium hydroxide. So when you
Sir,
break down calcium hydroxide, what does it become? It becomes Ca plus 2 and it becomes OH minus 1. And
it will
here it
become
becomes
like
H plus and Br
CaBr2
negative.
plus 2H2O or CaBr2 plus 2H2O.
Right. So this forms CaBr2 because positive goes to negative. And here water is being formed, and once you balance it, it gets this. Now you understand that all neutralization reactions are exothermic. All neutralization reactions are exothermic. Did you understand?
Yes, ma'am.
When all neutralization reactions are exothermic, what does that mean?
Like
What does
they
that mean?
use heat.
That water will be formed.
Yes, ma'am.
But you understand the amount of energy released would be 57.1 kilojoules per mole of water. When 1 mole of water is being formed, you understand that 57.1 kilojoules of heat is being released. This is the heat of neutralization. That means if you mix an acid or a base in a beaker, you understand? When you mix an acid and a base in the beaker becomes warm, right?
Ma'am, 1 kilojoules of heat is released.
57.1 kilojoules.
Acha, 57.5.
Did you understand?
Yes, ma'am.
Any doubts in this?
No, ma'am.
Are you sure?
Yes, ma'am.
Next, what do we have? Now, in this example, if I tell you that we have two H2O being formed, what do you understand from this? Two H2O being formed means what? Two times,
Two
two
molecules
times
of water.
water. So, how much energy? Two times 57.1 kilojoules. So, that
Ma'am,
is
it will
2
be,
times 1 is 2. Two
ma'am,
sevens
that
are
will
14,
be, ma'am, 10
10
point, 104.2. 104.2.
kilojoules. So, you have to first balance the equation and check how much amount of water is being formed. Whatever amount of water is being formed, that much water shall be released in the form of heat. Did you understand?
Yes, ma'am.
Any doubts in this?
Oh, ma'am.
Okay. Now just have a look. So let's suppose if I give you AlOH whole thrice plus HCl. So it forms H plus and Cl negative. And here it forms Al plus 3 and OH negative. Did you understand? So
Yes,
positive
ma'am.
goes in negative and what does it form? It forms AlCl3 plus H2O. And how much H2O does it form? It forms 3H2.
3H2O.
Are you understanding?
Yes, ma'am.
So that is the concept. That is the concept. And how much energy shall be released? 3 times 57.1.
171.3 kilojoule.
Correct. 3 times 57.1 kilojoules of heat shall be released. Understood or no?
Yes, ma'am.
Any doubts?
No, ma'am.
So this is going to be my neutralization reaction. Done?
Yes, ma'am.
Right?
Yes, ma'am.
So this is how it. Now you have to understand that what is a salt? Salt is any compound whose cation is anything but not H plus, and whose anion is anything but not OH negative. Do you understand a point? Whose cation is anything but not H plus, and whose anion is anything but not OH negative. Are you understanding my point or not?
Yes, ma'am.
Right. So this you have to understand. This you have to understand. Right. So for example, if I say, did you understand this concept? So any compound whose cation is anything but not H plus, and anion is anything but not OH negative. Let's suppose if I say HCl. So you break it down into cation and anion. So you say that cation is H plus. If cation is H plus, what does that mean? If cation
Ma'am,
is H plus, what does that mean?
ma'am, H is positive. That positive ion.
Right. So this is an acid. If I say LiOH, you break it down again. You say that cation is Li plus, anion is OH negative. If anion is OH negative, that is definitely a base. But if I say NaBr, you break it down, cation is Na plus, Br is negative 1. This is a cation. Did you understand?
Ah, yes, ma'am.
So this is a cation, and this is the anion. And the anion is anything but not. And cation is anything but not
H plus.
Right. Did you understand my point?
Yes, ma'am.
Hence NABR. Got my point or not?
Yes, ma'am.
That is the concept. Got it?
Yes, ma'am.
Any doubts in this?
No, ma'am.
So this you have to understand. Cation and anion is there. Understood?
Yes, ma'am.
So this is definitely a salt, not an acid, neither a base. Got it or not?
Yes, ma'am.
Right. So that's how we basically work with the reactions. Is the displacement, double displacement, precipitation reactions clear?
Yes, ma'am.
Have we done displacement reactions?
Yes, ma'am. We have done
We have done. Have we done non-metal displacement reactions also?
it. Yes, ma'am. Ma'am, that also like
Okay.
the non-metal, ma'am, the more reactive non-metal like KCl plus like KCl plus O.
Yeah,
It will give me K2O plus Cl2.
right, right. So with this, we are done with the types of reactions. Okay. Uh, Today we'll end up here itself at 45 minutes. Tomorrow, can you do a 45 minutes class? Sorry,
Ma'am, tomorrow for how many minutes?
45 minutes.
Ma'am, actually